Hi, I'm Ismail. Tonight, I will discuss the bouncing effects, right? The, or Swiss bouncing effects, right? Which is occur in all uh, mechanical switch, right? Due, due to the mechanical context. That's not what we can say directly change from one state to another state. Okay, so this is simple. The changing from high to low. Okay, so whenever it change, whenever we press, for example, we press button for this is active low. Right? First of all, this is the active low, and know, it rapidly change a very high frequency uh, from high to low, low to high. Right? Change rapidly change uh, from 1.6 millisecond to 6.2 milliseconds. Again, this is due to the mechanical effects of bounce. So when you press the button, right, you can hear it takes number of clap actually, right? Not one clap. Mm, so for the processor, right, for example, later we see. I use 14 megahertz operating system, operating frequency. Therefore, it can simple assume that one clock equal to one execution, one execution. Or but the in the STM32, it takes about 0.25 or 1.4 clock to detect the change in the interrupt for the extended interrupt inputs, for example. Right? But for say one executions uh, of that processor is 0.25 35 microsecond, so it takes for 2 milliseconds, so it's already read about 80 times 80 times sample. So it can be high low low high high low high low, and then we cannot determine the correct level, right, in the end. So for example, if we have later we will write code just to increase the say 7 segment. When you press it without these the bouncing effects technique, the bouncing effect techniques. So what we have, uh, example, we want to count it, the counter should count by one each time we press a button. So if we count uh, numbers of, for example, maybe say 40 times or 30 times. So from one, for example, so the count will change to 41, 38, whatever it is. It's not indeterminate. So how to solve it? Okay, in the video 2B, I show the way how we sample, SW1 the previous and SW0 the present, right? So we can see it in 2E. Right? Sure, we can see that. So this is, for example, that previous one 0 and now it's 1, right? So you can see that no change detected. Means that the label still at low, right? Because previous low, now low. If previous high and low and now high, so we can detect that there is a change. You can see the each here positive trailing, right? Positive trailing change from low to high. Uh, so and then this time between the first sample and the second sample, or first and next sample, like present and next sample, it, it should be about 10 millisecond, right? Minimum of 10 millisecond. But it depends on the button or switch that you you get from. For example, if you get from Jalan Pasar, normally it takes more time maybe. And again, it also depends on your configurations of the switch. For example, for the blue button that we use in Nucleo, it has the low pass filter, right? Low pass filter. So means that it's it's it suppress the high frequency and retain the high frequency, the low frequency. However, we just reduce it. We just reduce, not 100%. Eliminates that bouncing, that bouncing. So the correct way to write code, right, without using the interrupt. This is, I'm not using the interrupt. Yeah, you can see the code here. So each time we read the previous into SW1, so SW1 hold the previous, and then SW0 we update with the new the present button, status of the button. Then from that we compare, and then from that we also we determine either it is press, it is uh, what just release, it is what release, or it is not press, right? Not press or press. You can determine it from this diagram. You can see it clearly, right? 1, 2, 3, 4, right? So 1, no change, 0 to 0. 2, 0 to 1, change from low to high. And then 3, from high to high. For example, this is 85, for example, 85 button. So it means that you not release the button. And then this one you can see that from high to low. It means that, for example, against it is active low, active high button. So you release the button. Okay, so we can use these differences in writing a code. All right, while in the interrupt, right, what we can do is we stop the process of sampling of the interrupt, right? Once we get the change, right? Once we get the change. So here you can see that, right, when we press the button, so it change to low and then change to high, a very high frequency, right? About 6.2 millisecond or 5 millisecond. Right, after that it's stop. Right? After that it's stop. So what we do is we relay the reading of it, right? Of it. That's I will show you in the code later. Okay, now we see the just go to the the previous code in two. Sorry, this is to B. This code is into to C. Right? Yeah, this is sorry. This one is in. This code is into to B. Okay, you see code. You can see the code later. And then, okay, let me see. If I press the button, okay, you see, sometimes can you see that trigger, right? That is false trigger. Okay? I press once, but it's changed, right? So it changed, especially when you press it, not what stable, when your hand, your finger is not stable, then you can get the changes of that. So to get rid of it, it's very simple. So we revisit the code, the previous code. So remember to set this PC13 to GPIO, extended interrupt 13, and LED to GPIO output. And then remember to set to the button is active high, active low, sorry. So we use the interrupt falling edge, with falling edge trigger. That means when we press the button, it will interrupt. When it changes from high to low, we interrupts the processor. Okay, right. So then remember to enable the interrupt NBIC. Then after you generate code, then write the code like this. It's simple. It's nothing. So first you look in the main program, the main function. Sorry. So here we can see that first I off LED, then here I delay for 2000 seconds, 2000 seconds, right? We can close this one, just close this one. So there is no change due to the main program, right? But my heart want to let it there. So this one we toggle it, right? Toggle the LED, right? Toggle LED at interval of say 2 seconds, 2 seconds. Then in the GPIO extend in the GPIO extended interrupt callback, or normally we call it as interrupt service routine. We wait for the button. What button said? The button pin, right? The button pins, or the button pin is we already label PC13 with button pin. Then if you press it, then it will toggle. We press once, but because of that bouncing effect, then it will, right? It retriggered. So maybe 0 change to 1, 1 change to 0, and then 1, 0 change to 1 again. So you see that's correct, but actually not, right? Because it changed 2 times, three times, yeah, 2 times, 1, 2, 3, 3 times. Odd changes. So you see, just like you press, it will toggle, But it's happen if that's happen even time. For example, from 0 change to 1, 1 change to 0 again. Then you see, oh, there is something wrong. You can detect wrong. The 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 problems there. Okay, right. So what we can do? So first, we go to the folder, the driver, right? Driver. Okay. Find out the driver, right? Driver. Why? Oh yeah, driver. Right? Go to driver. Okay, then you go to the user tick and include them to the header and C file means to include to the header file, header subfolder. Then you drag that one, the user tick to source. Then after that, okay. So we're going to use this. We're going to use what? So we're going to use the check elapsed time. Okay. So the function 6 check elapsed time. This function returns -1 or -1 if not valid number. Return 1 if duration from previous interrupt greater than time gap. Okay. That means, right? That mean what? That means that now we can resample. Right? So it means that more than say 10 milliseconds. So now we can resample. Resample the button. Or read that changes. Right? And return 0 means the changes happen less than the time gap. So you can set your own time gap. But before that, we need to init the tick timer. So just go here in the main program, right? In the main program here, then we init, right? Initialize the tick timer because we're going to use one. I set one, right? Then on top of here, okay. Then you can what? You can do something like this. Okay? You allow the interrupt happens, right? But you recheck if that is right. If the time is not out, right? Not out or out, then you simple it. Okay. or you can do I don't want. Maybe you can type if, right? If what? If the check time elapse, check time elapse, elapse time. Okay. So we set to one tick. So this one should start from 0, and the tick gap between the, say, 10 milliseconds. Right? You can put 50 milliseconds, and you feel that the what the bouncing time of that button more than 50, right? More than 50. I mean more around 50 milliseconds. Less than 50 lah, less than 50. Okay. Then right. Then we check if that happened from here, right? Then we toggle it. Right? So check if the interrupt occur, it will not being served if the time still not elapsed from the previous interrupt. It means that. So if the interrupt happens after the elapsed time of the previous interrupt, then it will be served, right? Then it will be served. So that's all the code, right? That's all the code. Compile it. Hopefully we have no problem. Yeah, we have problem. I think we have problem because we not include, right? Because we not include. We have warning there because we not include the pound inc control space double quote use control space tick. Right. Later we can apply this. Okay, we compile it. Later we can apply this technique to to any number of push button. For example, sometimes we love to write code to read the push button, right? By let that input button become the extended interrupt pins, right? So, for example, we have what? We have up down counter. So the up and down counter, maybe we can combine this together. Becomes the what? Become once some sort like functionality when you press button, right? Then we use this elapsed time serve. Okay, right. I run again code, and then after that, then we go here. Okay, it's downloaded now. Now, if I press the button, okay, I think I should stop that toggle because it's misleading us. It's misleading us. So I stop this. Okay, just Control 7. So we do nothing there. Then we run again. Click OK. This is also allow you to check either that 50 milliseconds is enough or not. Right? Allow you if the problem persists. What you need to do is to lengthen the time for the elapsed time shift, right? From 50 to 150 for example. Okay, now I repress the button to show you the effect. Okay, you see we still have the problem sometimes, but now no, we don't have. Okay, that we have problem. Okay, so what you do, just place 150 for example. So this totally, I think we reduce the problem that we have, but sometimes due to my hand. Okay, now I press the button. You can see that we have no problem. So you have what? You see how the what elapsed patterns, the bouncing effect can be reduced by these simple debouncing effects techniques, right? Just use the check elapsed time, which is lengthen, uh, ensure that the second sample of the interrupt happens after the elapse, the time elapsed, right? The time elapsed, the elapsed time is up to you after the previous or the previous interrupt. That's all. Bye bye.